Okay, so we're on page 2, or example 2 of 6.1. We're writing the equation of each one of the lines. So the equation of each one of the lines, and the equation that we're talking about, so equation, so this is the key word, equation of each line. What we're now learning, and it's a new thing, and it's gonna stick with us forever, is y equals mx plus b. We want to fill in the m and fill in the b and leave the y and the x in the equation. So this slope is actually my m, lowercase m. My y-intercept is actually my b. So we're just filling that in. So we're going to go y equals, this is a lowercase. So I need you to know this is lowercase for this, all of these guys here, right? They're all lowercase. Okay, so don't switch to uppercase in math. Math doesn't go back and forth between upper and lowercase. So y equals, m is the negative 4 over 3. You can leave the negative in the middle or in the top. Make sure that this x is written in the middle of the line, and then plus 9. We assume it's a plus. If there's no sign, we assume it's a plus. Okay? If the slope is undefined, then I know, so in my brain, I picture these. You're always allowed to picture it. So this is my brain thinking undefined, which means it does this, up and down. And if I'm drawing a line that goes up and down, that means that it is got an x-intercept, right? So it's going to do this. It's going up and down through my x-axis. So it's hitting the x-axis, which is why there's no y-intercept. So my equation is just x equals 8. It's why it's telling me it's only going through 8. If my slope is 0, so I'm drawing this one, if my slope is 0, it's doing this, and it's telling me there's only a y-intercept, it's only going across this way, and it's never going to touch the x, so it's going to be y equals negative 3. So y equals, which goes across, x equals goes up and down. One more time, m equals negative 2, b equals 5, so going back to my equation, I'm doing y equals negative 2, x goes here, and plus 5. So you're just always putting in, this goes in for your m, and this goes in for your 5. Okay. Then here we've got a concept, a situational question where it's cost and days. Y-intercept is also called a vertical intercept, or you can call it the C-intercept, cost intercept, right? So vertical intercept. So on this graph here, I'm going to say that my B is 10, and I want to do my rise and my run. Your rise and run doesn't have to start here. I can do any right angle triangle. My rise, you want to write this down. I want to see the work. Rise is 2. Don't say 2. You have to look at the scale. On anything that has situational stuff like cost and this, you want, or anything on a graph, really, you have to look on scale. Oh, anything on a graph. Don't say 2 squares, it's 10. I'm going to star that. Everyone says 2. It's actually 10. 2 squares is 10. And my run is not 3. It's not 3 squares. It's 6. You have to look at the scale. So then my m equals rise over run. Yes, I want you to write the formula with the m equals. And my rise is 10 over 6, which you reduce. ARF stands for always reduce your fraction. Right? So always reduce fraction, ARF, which will be 5 over 3. So then my equation, oh wait, what am I asked for? In this question it says equation. So I want to do the equation. So then over here, therefore, y equals m is 5 over 3. The x goes in the middle. Notice I'm putting it in the middle. And then my b, what's my b? 10. So plus 10. Okay, I'm going to pause the video there, and I'll do a different video for the graph below here.